This is Dr. Indradeep Kumar, Assistant Professor, IARE, Hyderabad. So now in this video we will discuss the question bank module 1 part 5. So this will be the last video for the module 1. Okay, so here. Now the question is, determine the thickness of a 120 mm wide uniform plate for safe continuous operation if the plate is subjected to a tensile load that has maximum value of 250 kN and a minimum value of 100 kN. The properties of the plate material are as follows. That properties is given, right? Limit is that endurance limit stress as 225 megapascal and yield point stress as 300 megapascal. The factor of safety based on yield point may be taken as 1.5. So thickness is that width is given. We have to determine the thickness, right? So let's see. Let's write what is the required. T equals to what? Right? W is given as 120 mm. Okay. Then now maximum load, that P max or W max, you can say W max is given as 250 kilo Newton. W mean is given as how much? 100 kilo Newton. The property of this one. So now endurance limit, that sigma E is given as 225, that is 225 megapascal, and sigma YT is given as 300 megapascal, and factor of safety, that N is given as 1.5. So these data are given. Now what we have to find, that thickness we have to find. Means what? Thickness, where that area will be there. So area is equals to what? W into T. So from here only we will find T. Okay. So now just see here that from Suderberg equation, that SM, because Suderberg equation is for yield stress, right? So sigma M by SYT, that is yield, plus sigma B by SE equals to 1 by M, that is there. So this formula we will use to solve, where sigma M is what? Mean stress. Sigma B is what? Amplitude stress, or you can say the variable stress, that sigma V, and sigma YT yield strength, sigma E endurance limit, and N as the factor of safety. Where sigma mean, how we will find sigma M? That sigma max plus sigma mean by 2, or you can say what? That in terms of area you can, that load you can find, and then you can, and sigma V is sigma max minus sigma mean by 2 in terms of. Now what is required? Sigma max, sigma mean. So sigma max will be equals to what? Right, P max by area, right? Sigma mean equals to P mean by area. So P max is how much it's given? Just in the question, P max is given 250. So sigma max will be equals to 250, and area is what? 120 into T. Sigma mean is, that is 100, that P mean is 100 divided by 120 T. Now just put these two value here to find sigma M, sigma V. So see here, that is given just. So width of the plate, W as 120 mm, SYT 300 megapascal, SE 225, and N as 1.5. Right? They just assume instead of P max, P mean, they have just taken here, I am taking that P1 as 250 kilonewton, that is P max, and P minimum considered as P2 as 100 kilonewton. So instead of writing P max, P mean, we can just write P1, P2. Now maximum stress will be what? Sigma max by A. So P1 by A, that is 250. After converting into the Newton, 250 into 10 to the power 3 by 122 megapascal. Similarly, for minimum, okay, stress sigma mean equals to P2 by A. P2 is 100 into 10 to the power 3 by 120 into T megapascal. Now we have sigma max, sigma mean. Just find mean and amplitude, right? Or alternately. So mean stress sigma M is what? Right? Sigma max plus sigma mean by 2. So 250 into 10 to the power 3 plus 100 into 10 to the power 3 by 2 into, because this 2 is there, and by this area 120 into T. So after simplifying, what we will get? 175 into 10 to the power 3, or you can simply just after adding 250 plus 100, that is 350 by 2, 175. 175 into 10 to the power 3 by 120 T, that megapascal. Now amplitude stress, that sigma A or sigma variable is sigma mean by sigma max minus sigma mean by 2. So 250 into 10 to the power 3 minus 100 into 10 to the power 3 by 2 into 120 T. That gives you what? How much? 75 into 10 to the power 3 by 120 megapascal. Now next step is what? Just apply the Suderberg equation. So what was Suderberg equation? Sigma m by SYT plus sigma VE by S endurance, right? Endurance limit equals to 1 by n. Right? Sigma m, just now we found how much is there, that is here. Right? So put that value 175 into 10 to the power 3 divided by 120 T. So this is sigma m divided by SYT, that is 300 is given. Right? Plus sigma V, we found here 75, this one. 75 into 10 to the power 3 divided by 120 T. So this is what? Sigma V value divided by what we required? SE, the C of the formula. So SE is given as 225. That is equals to 1 by n. N is given as how much? That factor as 1.5. Okay. So now after this, what we can write? This is just simplifying 175 into 10 to the power 3 divided by 120 into T into 300 plus here 75 into 10 to the power 3 divided by 120 into T into 225, that is equals to 1 by 1.5. This value directly you can put into the calculator, or you can further simplify like just by cancelling these zeros, right? Here also you can cancel all the zeros, right? And then just simplify and find this value of T. Okay, so after finding this, what I will get? This value of T as 11.45 mm, or that is approximately equals to 12 mm. Right? So just see, once again I'm just clearing how to find and what is required actually. So what is given? This time we have to determine the thickness of thickness. Thickness, what is required? Area and width is given. So width into thickness will be the area. Now once we have the area and other things like load, endurance limit, these things are given. So first again like the same procedure, what we will do? First we will write all the given things and what is required. So here in first word itself it's written determine the thickness. So first T equals to what? Then width is given 120 mm. W max is given here as 250 kilonewton. So you can write 250 into 10 to the power 3 kilonewton. W min is given as 100 kilonewton. That you can write as 100 into 10 to the power 3 kilonewton. Sigma E, that is given endurance limit stress, that is given as 225 megapascal. That you can, because it's a Newton per mm square. That same you can write 225 Newton per mm square. So that already we are using here in kilonewton. So that's why I has to convert 250 into 10 to the power 3 Newton. Why? Because after converting megapascal, that comes Newton, not in kilonewton. So all should have the same unit. It's not like that one you are using in kilonewton and another one you are using in Newton. So all should be or else just convert this into kilonewton. Okay, so that will be 0.225 kilonewton per mm square. Now directly you can use 250 and 100. No need to multiply by 1, that 10 to the power 3. So what you are using, according to that only you have to take the units. So everywhere the same unit should be used. Okay. So now sigma YT 300 megapascal, that gives what? 300 Newton per mm square, and N as given as 1.5. Okay. So now these are the given data. Now what we have to do? Just apply the S, that is there. What? That is yield point is given. So yield point means what? Goodman we can apply? No. Goodman yield point is not there. For Suderberg only yield point condition is there. That is the only difference between Goodman and Suderberg. Okay. So now apply the Suderberg equation, right? So Suderberg equation is what? Sigma m by SYT plus sigma v by SE equals to 1 by n. So SYT is given, SE is given. What we have to do? We have to find sigma m and sigma v. So sigma m, that is mean. Sigma mean is what? Sigma max plus sigma mean by 2. Sigma v is sigma max minus sigma mean by 2. So that is here that formula. Now what we have to find? Sigma max. Sigma max is what? That P max by area. Sigma mean is what? P mean by area. Right, just put here. Right, so after finding, also separately find here P max by area, P mean by area. So sigma max will be equals to how much? This here. So that after that sigma max is what? P1 by A, where P1 is the maximum, at 250 into 10 to the power 3. Area is how much? 120 into T. So this is your P1 by A, that is sigma max value. Similarly, for sigma mean, that is P2 or P mean by area. P mean is how much? 100 into 10 to the power 3, because we converted into Newton per mm square. So 100 into 10 to the power 3 divided by 120 into T, area. So now we have sigma max, sigma mean. Just substituting the value of sigma mean and sigma amplitude or variable and sigma v. So sigma m equals to what? Sigma max plus sigma mean by 2. So just put the values. Sigma max is how much? 250 into 10 to the power 3. Sigma mean is 100 into 10 to the power 3 divided by 2 into 120, because this is the whole part of sigma max plus sigma mean, that divided by 2. So after simplifying, what you will get? 175 into 10 to the power 3 by 120 T. This further also you can simplify by putting into the calculator. I did use the calculator, that's why this is here. So further you can simplify, but whatever the value you will get after solving this divided by T will be there. So similarly for sigma A, that amplitude is stress, or that is, you can say it's the same only, that sigma V, that is equals to sigma max minus sigma mean by 2. So that will be equals to 250 into 10 to the power 3 minus 100 into 10 to the power 3 by 2 into, so again this value is for sigma max minus sigma mean divided by 2. So after simplifying, what you will get? 75 into 10 to the power 3 by 120 T megapascal. Now what we have? Sigma m, sigma a. Already we have SYT and SE and factor of safety, that and also is given. So now we apply the Studerberg equation. So after applying the Studerberg equation, what you will get? Let's see here, 175 after putting the value. So here that sigma m value is how much? 175 into 10 to the power 3, right? Sorry, 3 by 120 T, right? This is for sigma m, whole divided by SYT. SYT is how much? 300 plus, now sigma v is 75 into 10 to the power 3 divided by 120 T by, or divided by how much? 225 equals to 1. So now let's see here, 10 to the power 3 by 120, I am taking common from these two. So 10 to the power 3 by 120 T common. Now what is here? 175 by 300 plus 75 by 225. Okay, this we can simplify or just put into the calculator and you will get the value. Just let's say simplify. Okay, 225. So 25, I am directly dividing by 25. 25 9 is 225, 25 3. Similarly 25. Okay, 12 here 7. Okay, so now what we have? 7, 10 to the power 3 by 120 T, 7 by 12 plus 1 by 3 is equals to 1. Now this takes LCM. LCM will be 12. Simplify, then cross multiply, and then find the value of T. So that T will be equals to how much? 11.45 mm. That is approximately equals to 12 mm. Okay, so just if you know the way how to find this, what we did in class. If load is given, then we found sigma mean and sigma A. Directly in terms of sigma A, sigma B is there, then no need. Otherwise load, maximum load, minimum load. Or now if maximum load, minimum load is given, then just mean value, that is sigma or load, maximum load plus minimum load divided by 2. For sigma, that sigma V, maximum B minus minimum B, or minimum stress divided by 2. Now with that we can find. In question, most of the question we are seeing that SYT, that and the SE, that is given. So only the thing how they are giving the maximum minimum value in terms of load or stress that we have to apply. The only difference in Goodman and Suderberg will be this one. Here that is SUT, that as ultimate will be there, and in this case it's a YT, that yield is there. That is the difference. So just you have to remember that these things will be given in the question, most of the question. Sigma m and sigma v you have to find. For that they will give you either the range of the force, that is range of the load, or directly they will give minimum and maximum load. If range of the load is given, means also whatever the starting is like 5 to 100. So this 5 will be the minimum and 100 will be the maximum load. So don't confuse with no, directly it's not given maximum load and minimum load. Once range is given 5 to 100 means 5 is the minimum load and 100 is the maximum load. So now P mean will be equals to 5 and P max or W max will be equals to 100. Now just apply, divide by area, you will get sigma m, sigma v, sorry, sigma mean, sigma a. After sigma a, just find sigma m and sigma v. That's all. Substitute in the Suderberg equation and find whatever the missing value is there. Right. So in some case they will ask the, like here in this question thickness was there. So instead of thickness they can ask what the width of that one. Or instead of this they will give this one. Then they can ask what is the factor of safety. One question already we had seen in the previous video. You can see to find the factor of safety. Right. So depending upon what the thing is, only you have to remember this equation for the Goodman and Suderberg, but the difference in Goodman will be UT. All will be the same way. You can proceed. Find sigma m, sigma v, substitute in this equation. If S that Goodman is there, then they will give you the SUT value. If Suderberg equation you have to use is YT. Means if suppose SYT is given, use Suderberg equation. If SUT is given, use Goodman equation. That is the only difference. Remaining all the steps will be same for all the question. If Garber's is there, then only with this the value will be the square one. That only you have to remember for the Garber's, because Goodman and Suderberg is for linear one only. This one, and Garber's is for non-linear also. Right. So for non-linear that will be the power 2 for the this one Garber's equation. So don't confuse with all the three. Only just slight difference is in Goodman and Suderberg. That is in Goodman SUT, Suderberg SYT, and in Garber's this second part, that sigma v by SE whole square will be there for Garber's equation. Right, depending upon what they are asking, just substitute the value and get the answer. Okay. So after this, that we got that T equals to 12 mm, that approximately equals to. Okay. So if you have any doubt in any steps or anything, you can just comment on the video with a particular step so that I can clarify, or you can directly contact to me regarding this question. Okay. So you can just comment on the video or you can simply contact. Okay. So you can refer THG action again for this book, so for this question also. Okay. So thank you.
Like, share and subscribe. Hit the bell icon for more updates.